Hello everyone, this is Shalini Sheetal from Shecoders, and today we are going to cover the next topic in our series of Python tutorials, and it is about modules and packages in Python. So one thing to keep in mind is that Python is very famous and easy to learn and comes in handy just because of the modules and packages it possesses. It has many built-in modules which are really handy and can help you in a lot of ways which you can't even imagine. So it is very important that we learn about the most commonly used modules and later you can explore them deeply if they interest you. So what are Python modules and packages? Basically, modules and packages are two mechanisms which are used for modular programming. Module programming, as I have already mentioned during functions, it refers to the process of breaking a large programming task into smaller, separate, and more manageable subtasks or modules. Individual modules can then be buckled up together like building blocks to create a larger application. So, when you have something difficult you are working on or a huge complex project, you can break it down into smaller modules and smaller fragments. You can then work on them individually and then combine them into an entire large project. There are several advantages of modularizing code. The first major reason, which is very obvious, is, is its simplicity. So rather than focusing on the entire problem at hand, a module typically focuses on one relatively smaller portion of the problem. If you are working on a single module, you'll have a smaller problem domain to wrap your head around. This makes development easier and less error prone. Second is maintainability. Modules are typically designed so they enforce logical boundaries between different problem domains. If modules are written in a way that minimizes interdependency, there is decreased likelihood that modifications in a single module will have an impact on other parts of the program. So if you break down your code into different fragments and then work on them independently, then even if go something wrong, you go somewhere wrong, then there is less chance that your entire code will break down. There will be errors in just one part of the program, in just one part of the project, and the remaining of the project will work just fine, and you have to work on that single piece of error. It will be easier to identify your mistakes, right? So you may be even able to make changes to a module without having any knowledge of the application outside that module. You can ask for help to others and they can help you sort your problem. But if they don't have about any idea about the project you are working on and you just hand them over the entire project and say that I'm having some errors, kindly go through it and sort it out, it will be quite difficult for them, right? But if you have error in one single piece of your code and then try to figure it out, it will be a lot easier. So this makes it more viable for a team of many programmers to work collaboratively on a single large application. The next point to be noted is reusability. Functionality defined in a single module can be easily reused through an appropriately defined interface, obviously, by other parts of the application as well. So the duplicacy reduces. You don't need to write the same code again and again. You can just import the particular module. You can use the same module again and again instead of writing the whole piece of code together. The last one is scoping. So modules typically define a separate namespace, a separate area which helps avoid collisions between identifiers in different areas of a program. So there won't be overlapping of variable names. They are a different namespace, so collisions can be avoided easily. So because of these obvious reasons, four typical main reasons, they are very handy and are of enormous use in development using Python. So functions, modules, and packages are all constructs in Python that promote code modularization. We'll be looking at packages lastly. Functions we have already covered in a previous tutorial thoroughly, and today we are going to learn about modules and packages. So firstly, let us know what modules are. So there are basically three different ways to define a module in Python. A module is actually a piece of code. It can be a function, it can be a variable, it can be variables plus functions plus a class. It can be anything. Any piece of code written in Python can serve as a module, and you can use that by importing it by using the keyword import, and you can work on it. So let us go through an example by learning what are the ways in which a module can be defined. The first one is that a module can be written in Python itself. So this is the first example. We'll be going through it. There are also other ways, like module can be written in C and then loaded dynamically at runtime, just like the regular expressions module. So, and the last method is that a built-in module is intrinsically contained in the interpreter, like the ITR tools module. So many built-in modules are already present, like some functions, for example, sum, max, min, these are predefined and they are automatically loaded when the interpreter starts its execution. Whenever you open Python, you don't need to import the built-in module explicitly. They are already preloaded in the interpreter, and functions like sum, length, mod, etc. can be directly used without importing any module specifically. So, what if you want to write a predefined module, a custom model yourself? You can do that by simply writing a Python file of your own. So, in order to write a Python file, you have to use this syntax: two percentages followed by write file and the name of the file you want to give to. Here I have considered it as an example. If you look at the root directory, there are just two files here, namely these two, and there are no other Python files present. But the default extension for Python is py, and example.py is the name of the Python file we are going to write our code into. So I have taken a string and an array. Array is basically a list here. We have already covered that. And there is another function here named foo, and it prints the argument which is passed on to it. There is also a class here. It doesn't have any specifications. I have simply mentioned pass, indicating that there is nothing to do inside it. It is an empty class. So for example, when we execute it, give the output writing on example.py, and if we check the root directory now, then there is another py file present here, and if we go through it, then you can see all of the code which we had executed is already present here. So the example.py file has the string, the list, as well as the function and class we have written here. Now, for example, if we want to use this module, this piece of code again and again, then instead of explicitly writing this code and duplicating it for multiple times, we can simply import this module. And for importing it, we use the import state keyword followed by the name of the module we want to import. For example, we imported example here, which is the name of the module we defined in this case. And if we can access it by using we can access all the data variables and classes functions inside it using the dot operator. In this case, the name of the string variable was s. So for printing it, we have to mention the name of the module dot the variable name we want to access. So it will be example.s, and that will give us the string which we had passed, namely it is let us learn about modules and packages. I have also passed a number to the function that we had, and we have passed 10 here, and it is executing this print statement, namely arg is equal to 10, which is the same number we passed here. If we pass something else, then it will return the required thing. We could have also accessed the array similarly. For in order to loop through it, we have to use the asterisk symbol and then access it using example.a, and it prints all the elements of the list as well. So this is how you can write a custom module and then use all the variables inside it by using the dot operator. So the focus will mostly be on modules that are written in Python. The cool thing about modules written in Python is that they are exceedingly straightforward to build. All you need to do is create a file that contains legitimate Python code and then give the file a name with the .py extension. And that's it. There is no special syntax or no voodoo necessary for it. So nextly, we'll be looking at some of the commonly used modules which will come in very handy and there will be extensive use of it in your future. The first one is random. So as I've already mentioned, we need to import the module we want to use, and then if we check its directory, it prints all the methods and functions it has. So there are numerous functions inside random. you it just doesn't mean that you generate a random number and that's it. There are multiple functions inside it. For example, the shuffle function, we'll be looking at it shortly. The seed function, which is used to generate a random number, different random number every single time. Rand int, it generates a random integer within the specified range. And rand range is also the same thing, but you provide a step value and specify the number of random numbers you want and it will give you the required output. Uniform is also kind of similar. It generates the uniform distribution, the normal distribution within the specified range. So for example, if you want to use the function randint, then you can specifically import it because you want to use the randint function from the random module. So you write from random import randint. So we are basically importing randint from the random module. But if you would have just written import randint, Python cannot guess from which module you are trying to import it. You can use the syntax to import only a module and not any random function. If you want to import a specific function, then you have to mention the module from which you want to import it. So this will generate an error. You have to explicitly mention the name of the module. So here I have just specified the range inside which I want a random number, and the general syntax, as I've already said, it will be module dot function name. So if we execute it, it generates a random number, different random number almost every single time. And here, if you would have just written randint, that would have also worked because if you just import randint directly and execute it, it will also work because you have specifically mentioned randint. So you don't need to write module.function name. You can simply use the function name if you had imported it specifically. But if you would have written just import random, then you would have to use the module name dot function name. So if I make it more clear, if you use this syntax, then for each and every function, you have to follow the syntax of module dot function name. But if you use this syntax and you explicitly mention the functions you want to import, then it won't affect if you just use the function name separately. You don't need to mention the module name again and again in this case. So similarly here, you can import multiple functions, and I have imported another function, namely choice. And choice basically returns you a value from the range of values, from the arguments, list of arguments we have passed it. So here I have provided multiple numbers and it will always return me a number from inside of that list only. It won't give me anything out of the world. It will just return any number within these 5 numbers always. So choice is used when you want a random number from a specific uh, list of numbers or characters you have. Another handy thing which comes in modules is that you can import all the functions directly. If you don't know what functions you are going to use, it is better to import them all. So if you use the asterisk symbol, it indicates that you are basically importing all the functions, and then you can mention the module from which you are importing, and from random import star. So star indicates that you are importing all the functions and now you can use them all directly. For example, I had already mentioned the shuffle function. The shuffle function will basically rearrange the numbers you pass it to. Here the list is 10, 20, 30, 40, 50. But if we execute this and then check it out, then you can see the arrangement has been heavily altered. It doesn't follow the old order and it has been completely rearranged randomly. There is no specific pattern and you get a completely new sequence of numbers. Nextly, we come across the math module, and the math module is very handy when you are performing mathematical calculations or something like statistical data. You are dealing with statistical data, you're dealing in machine learning, data science. Math modules and NumPy or Pandas, they really come in handy when you are dealing with statistics. So let us go through some of the commonly used functions. I'm going to import all the functions so it will be easier for us. And the sqrt function basically is for the square root. It returns the square root of the argument. So you can use sqrt and pass on the argument and it will return the square root. It can be for integer values which are perfect squares, as well as it can also work when you don't pass on a perfect square. For example, here 20 isn't a perfect square, but it will return you the square root in float. Nextly is the ceil function. It will round the argument to the nearest lowest greatest integer, the smallest greater integer to the number you passed it to. Similarly, floor is the opposite. It will return the greatest lower integer you have passed the argument of. And the power function will raise the base to the power of exponent. And here the first argument passed is the base and the second argument is the exponent. So the syntax is basically power of base to the power exponent. And there are also all the trigonometric functions, for example, sine, cos, tan, everything, as well as the inverse trigonometric function. You can also calculate the inverse using the ready-made functions. The names are same, sin for sine, cos for cos, and so on. There are also logarithmic functions. For example, if you just write log of 45, it will return the log to the base of e, the natural logarithm, which is to the base of e. And if you want the base to be 10, you can explicitly mention it and you can write log 10. And as you can clearly see, these two values are entirely different because in the first case, the base is e, and in the second case, it is 10. Now, there are some constants in math as well, which are used very frequently. For example, the natural logarithm e is calculated to the base e, and you can directly write e, and this is the value of e. Similarly, there is pi, which is 3.14, and there is the fixed constant present in the math module as well. Remember, since I have imported all the functions and variables from math module, I can use them directly. But if you use them without importing the math module, it will give you an error, because in other cases, it will expect that e or pi is a variable name you are using. But since I have imported math here, the interpreter understands that I am mentioning the pi inside the math module. Nextly is the time. Time module is used when you are developing projects and you want, for example, a simple stopwatch or countdown or a clock. You can use the time module in that case. For this module, the syntax is similar. You need to import all the functions, or you can also import them separately. And the first function which we can use is the sleep function. The sleep function basically stops the execution up till the time you have passed on as argument. Here, if we let me execute it, it will be clear to you. Sorry, I haven't imported. Yeah, now, the first output is at 0 seconds, and if you observe, the second output comes in after 4 seconds to be precise. The second statement executed after some time, didn't give immediately, and if you increase the time increases again. I had specified 6. If I execute it now, you first get the statement at 0 seconds, and then exactly after 6 seconds, the rest of the code execute. So the sleep function basically halts the next part of program's execution, and then it can be used to slow down your code whenever you need to. Nextly, we you see the time function. The time function basically returns the number of seconds since 12 a.m. January 1, 1970. It is the epoch concept, and the time function always returns the number of seconds since that precise moment. January 1, 1970, 12 a.m. So if you want to convert it to a local time, naturally you are not going to use seconds always, right? They are of no apparent use. So if you want them in terms of date, hours, or minutes, you can use local time. And if you do that, sorry, there is some, this is, and if you execute it, you can see that the year is 2021, month is September, so 9, and today is 12th while I'm recording this session, and hour is 12:50, and this is the required time it returns. So text basically, I have given the variable name as the number of seconds we have passed till now. If you want the exact structure, date and time in the specified format, you can use C time. It will return the time as a string in an easier format. And if you execute that, it returns you the required time. You don't need to pass on the time function separately. You can directly use C time and it gives you the same result. Nextly, we come into a very big and useful module, namely Pandas. It won't be possible for me to cover it in one single class. There are numerous concepts, numerous facts behind it. So I request you all guys to go through it extensively. If you are interested for data science, machine learning, Pandas will very come in handy. So firstly, we look at one concept of pandas, which is series. A series is basically a one-dimensional array. You must be familiar with that. So a series in pandas is basically one-dimensional array which can store variables, objects of the same type. So here I have imported pandas as PD. You can import any module using an alias. So here I have named pandas as PD, and whenever I use the term PD, the interpreter understands that I'm referring to pandas. So I have taken a list here with just 3 elements, and if I basically turn it into series in pandas and then print it, you can see the output is returned with index values as well. 0 for 1, 1 for 7, and 2 for 2. The left side column basically indicates the indices, right? So I have turned this list into a series using this pd.series, and as argument I have passed the list I want to convert a series to. Now you could have also given a specified set of indices you want. It doesn't necessarily need to be numbers always. You can just pass on another argument as index and specify the indices you want. And then in this case, you can see the indices turned into x, y, and z instead of 0, 1, and 2. So you can also access each member using the index value. Using these are similar to key value pairs in Python dictionaries. So if you want to access a specific element inside a series, you can do that using the index value. As I've already said, you can turn dictionaries into series. The working concept is quite similar. In this case, as you can clearly see, that I have passed a dictionary in this case, and after I convert it into a panda series, the output is as such. Nextly, we come to data frames. Data frames are basically two-dimensional arrays. Series are one-dimensional and data frames are two-dimensional. Data frames have vast use in data science, I repeat. So if you want to pursue that line, then go through it extensively. I have taken another dictionary in this case, but here it is a two-dimensional dictionary since each value is another list here. So if I convert it into a data frame, as such, here we were using series, but now I'm converting it into a data frame. And if you see, there are two columns here and another column for the indices. And this is the two-dimensional array I get as the output. In this case as well, you could have passed the indices separately, and if I do so, this is the output you get. Instead of 0, 1, 2, now I have my custom indices passed on. Now, if you want a specific row of the data frame in pandas, you have to use the look keyword. So inside that, you need to specify the index value of the row you want, and here it is day2, and if I execute that, you get this exact row as the output. You could have changed it, you could have accessed day3 instead, and it would have returned you the third row. Nextly, we come across another module which is Seaborn, and Seaborn is used in data science, statistics, data analysis extensively. There are many preloaded data sets inside it which you can use and practice on. And here I'm going to load the most smaller data set comparatively, which is tips. And sorry, yeah, import Seaborn as SNS. So whenever I use SNS, I'm referring to Seaborn module. And after I load tips, you can view the first five rows using the head function. And this is basically the data frame we have. It is a pandas data frame, and it has numerous columns and rows inside it, as well as with the index values. And you can use the plot function directly with a Seaborn data set, and this doesn't return you any useful data if you directly plot it. So you will justify the specific kind of plot you want. If you want a scatter plot, and this basically gives you the relationship between the gender of the customers to the and how they relate to the tips they give. So it basically implies that females comparatively give lesser tips than male, because males have some peaks over here which is comparatively higher than females. So this will return you the relation between the gender and the tip they provide. You can also have a histogram, and you can mention the column you want, and you will have the frequency distribution directly. Lastly, I'll cover packages very shortly, very not I'll not go deep into the details because packages are vast and you need to have thorough knowledge if you want to implement those. They come in handy when you're developing a project or so. So let us look at what packages are. Packages basically allow for a hierarchical structuring of the modules using dot notation. In the same way that modules help collisions and overlapping between global variable names, packages help avoid collisions between module names. So a package is basically a directory, a folder with Python files inside it, and there is always a file with the name init.py. This is the point you want to remember. Whenever there is a package you want to make, you have to include the init.py as well. This means that every directory inside of the Python path which contains a file named init.py will be treated as a package by Python. It is also possible to put several modules into a package. So if you have many numerous modules which perform some relating tasks which are related to each other, you can have them inside a package, import that whenever you need to, and use them easily. So packages are a way of structuring Python's module namespace by using the dot module names. In modules, you were using the dot operators to access the functions, and packages are a way to handle modules. So a.b stands for a submodule named B in a package named A. Just like we were using the module.function name, this is a hierarchy: functions, then modules, then packages. So a.b, here A is the package and B is the module. Now, two different packages like P1 and P2 can both have modules with the same name. For example, A. Because they are inside different packages, you will access them using p1.a and p2.a. So Python will understand which A you are referring to. The submodule A of the package P1 and the submodule A of the package P2 can be totally different as well. So if you have same names, it doesn't matter. If they are inside different packages, Python will treat them differently. So just like importing a module, you can also import a package by using the keyword of import. So if you are working on projects, packages and modules come in handy. Go through them, go through useful modules like Cbond, NumPy, Pandas, many other. NumPy is a very useful module. It handles arrays very easily and there are many useful functions inside it as well. So go through it. All the best. Thank you.